Now, without further ado, let's get started with this event. Oh god, I'm so excited for this. The first part will be done by RSM and they will be introducing us to research and how to get started with it. And then we will open the floor to any questions that you people have for the panelists. There are two rules for asking questions. Please drop them in the chat box if you have any questions, or please hold on to your questions until we open the floor for you all to ask your questions to a panelist. Our panelists for today from RSM are Supriti Vijay, Aman Priyanshu, and Aditya Nirmale. To introduce our first panelist, Supriti Vijay. Supriti Vijay is an undergraduate third year student currently pursuing her BTech in computer science. She has had numerous publications in top artificial intelligence conferences like NLP. She has also interned with A-Star Laboratory, Singapore, foreign universities including the University of Copenhagen, as well as is currently an incoming research intern at Adobe. She was also awarded the MyTax Global Link Research Internship, as well as was among the 6 girls who were awarded the Adobe India Women in Tech Scholarship. Her research interests lie in natural language processing and social network science, and she's keen on working in AI for the benefit of her world. Over to you, Shriyanka.
Our second panelist for today is Aman Priyanshu. He is an undergraduate at Manipal Institute of Technology, pursuing a BTech in Information Technology. He has a keen interest in the field of artificial intelligence and cybersecurity and is working on research intersecting the two fields. His work primarily lies in the field of privacy-preserving machine learning and explainable AI. He has had numerous research publications in these fields, presented in esteemed conferences such as ICLR, CVPR, EMNLP, and ACM CCS. He also has a successful Q1 journal publication. Aman is currently interning as a research intern at Dynamo FL and is an incoming intern for the MyTax Global Link internship. Outside of his research inclinations, he has won numerous hackathons like HackerRx by Bajaj FinServ and the Code Innovation Series associated with GitHub. Aditya, Aaron, if you'd like to introduce the third panelist.
Last but not the least, the third panelist for the day is Aditya Nirmale. Aditya Nirmale is a third year undergrad pursuing BTech in Electronics and Communication Engineering with minors in Material Sciences. He's an active researcher in the field of electronics with interests in nanoelectronics, flexible electronics, and material sciences. Wow, he has patents in the area of flexible devices alongside multiple papers under review in Q1 journals. He is currently an undergrad researcher in Manipal and has been awarded with a couple of grants. He was also awarded the Summer Research Fellowship by Indian Academy of Sciences in 2021. The floor is yours, Shriyanka.
Now that we are done with the introduction of our stellar panelists, I'd like to hand it over to them to continue the event.
All right. Am I audible properly? Can everyone hear me?
Oh, yes, you are.
All right. So we will just be presenting our screen in a minute. So till then, I think we can talk about what research is. Now, research is about removing the limitations that our imagination imposes on our reality. Having said that, research in itself, the word research means seeking out and searching closely. So what you do in research is that you try to pursue your interests, you try to learn something new, and you try to hone those problem-solving skills that you have by challenging yourself in ways that have probably not been explored before. So the reason why undergraduate research is really important and why everyone should at least have some experience of research in their undergraduate days is because of the fact that you learn in-depth knowledge of that particular topic and you totally understand and have a fundamental understanding of that particular topic that you would like to pursue. Now, so before we go on to research, there are steps to any research process. Before that, you have to understand how to search for research papers, because what happens in research is that you have to have a fundamental background, you have to have a fundamental understanding of your topics first of all, and the second thing that you need to know is that what all research has been conducted in the field before. Now you don't have to know the entirety of it, because you can, like, if you're just interested in one particular subtopic of research, you can just look out for research papers beforehand, and then you can read about them and understand about the previous literature that has been published before in that particular field. Now I'll give you an example as of now. So I work in natural language processing. I'll give you an example. So I work in natural language processing, and in case that now if I'm totally new to this field and I just know that I would like to work in artificial intelligence, what I would do is that probably the first thing that I would do is that try to build my base knowledge in it. So that would include by doing courses on that particular and get courses on artificial intelligence and gaining a very basic understanding of mathematics, statistics, and probably anything else in order for me to understand the papers that have been written in machine learning and artificial intelligence. Now, if I'm looking for NLP research, what I would do next is that I would go ahead and look for, just type NLP research on the net and try to find as many research papers as I can find, and probably open any one that seems really suitable and to a subtopic that I would like to explore, let's say text summarization or even fairness or bias in NLP, and then try to find topics inside it. So that's how you start your research journey basically. So in this, of course, we'll be talking about how to begin how to begin your research journey and how everyone can basically search and how to write a paper, how to what are the different types of papers, and basically how you can understand and formulate your entire problem statements and how to begin your journey. So the next slide, that's searching for research papers. All right. So what happens is that the reason why we need to search for research papers is because of the fact that a lot of people have a lot of problems looking for papers. This is why we're going to be covering this in this topic today. A lot of people have problems looking for papers online. And the reason why we search for research, I think I've made it pretty abundant beforehand, because you need to have a fundamental understanding of all the work that has been done previously. So this is why you really need to look at papers beforehand. Either you do a literature review on that particular topic, or you're writing a review paper on that particular topic to understand what all research has been probably done before. Now, people have problem looking for papers that are relevant to your problem statement or any such thing that you would like to, any subtopic that you're looking for. Now, before that, you need to understand that there's an objective. So you need to first understand, before you look for any research papers online, you need to understand that you should have an objective before, as in what you're looking for, right? If you're writing a very vague topic, then you're going to get a very vague results as well. And it's very important to have an objective, as in why are you looking, what subtopic are you looking for? Because if you don't have an objective, a particular objective, it's going to be very chaotic for you to find a particular topic that you may enjoy. And it'll be very chaotic in the sense that it'll be like Trump's admin handling of the pandemic, and it's the kind of mess that we would not like to create. Right? So that's why an objective is that important. Now the next slide is that why should we optimize our research? All right. So the thing is that Google in itself has a lot of the reason why you should optimize your search is because of the fact that Google, now I don't know if a lot of people know this, but Google's search engine is responsible for almost 40% of the internet's carbon footprint. And this was like the British Environmental Consultancy in 2018 had said that the estimate of Google's carbon footprint is like they release 1 to 10 grams of CO2 in the air almost every single day. Now that is equivalent to a car running for 1 mile. So every search that you do releases 1 to 10 grams of CO2. And that's why you need really efficient searches, and not just to save our particular time, but to also reduce our carbon footprint. Because face it, climate change is occurring, and there is global warming in the global warming is a very prevalent issue right now in the right now that everyone is facing basically, and we can't keep ignoring this, which is why we do need efficient searches. And for every second, like I've put statistics on this slide, basically for every second that you're spending on Google, at least 23 trees have to be used up because of this, use up their CO2 sucking abilities. And basically it's very important to have very efficient searches. Now I'll talk to you about how Google search works, because it's very important to understand. All right. It is very important to, right. So it is very important to, all right, I'm so sorry. Yeah. Okay. So now the next thing is that in order to, why should we understand why Google search works? Okay. So in order to get the results we want, we need to understand how Google works, and then we need to deconstruct it, right? Like in order to manipulate the results, manipulate anything and to get the results that we would like, it's important to understand how Google actually works and how do we find the results that we want in order to find the search, in order to search whatever we would like to search. In this case, that what I mean is research papers. So when you're looking for research papers, what you do is that you need to try to find specific topics. You need to try to address specific topics. Now, before that, the Google search engine, all right. Before that, the Google search engine, now it takes into account the user's interest, their search history, their location, and a lot of other features. Now, Google is technically very notorious for the lack of privacy with respect to data, because of the fact, but at the same time, what they do is that they take in a lot of your data and then they use it in order to improve their services, so that you keep coming back to them. Now, so Google never stops reading your history, and by that it betters its efficiency, it betters its algorithm in order to understand which page is the most clicked, and in order to come up with a page rank algorithm which determines the popularity of a page. Now, the search results that you get in a Google search engine, what happens in that is that okay, so all the search results that you're getting, it's ranked, it's sorted in terms of the number of clicks that a particular website gets. It uses something that's called as the page rank algorithm that helps to determine the popularity of a page under a particular topic with respect to other pages. All right, and as you can see, the bubbles, the image that is being shown in the slide right in front of you. Okay, so as you can see that B over here, as the circle gets bigger, that is the most clicked website, and it uses this page rank algorithm in order to sort out the most clicked websites, and then it optimizes those search results and then sends them to you. And that's what the result that you get whenever you search for anything in the Google search engine. All right, and okay, so there's something else that Google does, is that for all the AI enthusiasts around here, maybe you know about this, that Google search engine uses BERT. All right, and so BERT in itself, okay, so BERT is not this yellow fluffy thing that you're seeing from Sesame Street. It's something that's a lot more scarier, and this algorithm probably is the reason why Google search engine works really well. What happens is that this in front of you, this image is the Google's BERT search engine. Now, the thing is, I don't know about the rest of you, but I tend to make a lot of spelling mistakes or grammatical errors while using search engines. And a lot of people even use abbreviations of some sort. So how does Google understand really well what you would like to speak? And how does it understand what you what you refer to, what you mean. For that, they use something that's called as the BERT algorithm. And what this BERT does is that it keeps learning on the data that each person inputs in. Basically, so if even one person is searching for something and then you correct it, and then what it does is that it takes those data real time, and then it trains on those data, and then it gives you and then, like, when you search something like RU, instead of using YOU, you're using the abbreviation U instead. And then when you're looking for any topic in particular, it'll ask you, you'll often see something called as do you correctly mean this, instead of that. So that's how BERT. So BERT is the reason why Google search engine works the way you see it. And sometimes even I can't understand those people when you write grammatical errors, and these errors and mistakes are genuinely so abstract. But BERT can, and it uses this information to improve your search results quality. And okay, so now we'll come back to the fact. So now that I've talked to you about how BERT algorithm is, and how Google does its search, and how it optimizes its search results, we should go back to the fact that how you get the results that you would want, right? So when you're doing that, you're trying to search for specific keywords that relate to your objective. And in order to do that, you need to understand how these keywords cause certain results to rank higher. Basically, what you would like to do is that you would like to search at probably academic. You try to use the list of search operators that Google has, or you would try to use certain academic search engines like Google Scholar or Microsoft Academic or Base or Core, basically to find research papers that are specific to your particular interests. And that's how you try to get the results that you would like. All right, I will show you. I'll show you. So what I'm going to do is that I'm going to show you a demo of how to search for research papers. Okay, I think my desktop is visible. Okay, so as you can see, like I told you that Google, what it does is that the lack of privacy in Google. So Google tends to read all your search history, and then it optimizes its search engine through that. But DuckDuckGo, now if I write over here, so like I said that I dwell in NLP research, so I'm going to type it over here in front of you. So if I write NLP research, this is what I'll get. I'll get NLP Research top papers from 2021 so far. Then I'm getting an article about natural language processing. And I got an article about neuro-linguistic programming that is not at all related to NLP research. All right. And it's very abstract. So in terms of privacy, what you're getting, of course, DuckDuckGo takes, is a very private search engine. And it does reserve your privacy, but then the search results that you're getting are really not that good. So I'm going to do the same thing, and I'm going to go to Google instead, and I'm going to go and write NLP research over here. As you can see, the first result that I get, according to my browse history, I got, even if I was the first person, because of the fact that Google has been trained on a lot of data, you'll get natural language processing, Google research, then you'll get the Stanford natural language processing group. And this is the most, so it's ranked, like I said, Google uses PageRank in order to rank the websites through their popularities, and that's how you can look for it. Now NLP research, let me look for a much more specific and a niche topic. All right, so let me look for text summarization. Now I will get a much more niche and a much more specific result for my search. But in this as well, I'm still getting blogs, and I'll get blogs about it. I'll get machine learning, I'll get any machine learning articles about it, basically. And I'm getting some research papers, but then it's not specifically research papers, right? So what I can do over here is that there is something called as, wait, I will particularly show that to you. Okay, so what you can do is to get specific keywords, like, to have the word Hindi. So what if I'm looking for topics that have the word Hindi in it? All right. So this is what I'm going to get. So I'll get all the search results that have the word Hindi in it. And if I'm looking for text summarization, all right, if I want text summarization to come alongside with it, this is how I can search for better results. So if I write text summarization in quotes and Hindi in quotes, I'll be getting specific articles that have the word Hindi and text summarization in it. Now, what you can do is that if you would like to only search for PDFs or any such thing, now this website over here, okay, so now for PDFs, what you could do is that you could write file type and then write PDF, okay. Now you'll just get PDFs in your search results, and this will narrow down your search, and you can efficiently look for whatever you want to find. Basically, the problem statement that you would like to find, or any subtopic that you would like to research upon, you can do so by finding and by efficiently looking at efficiently finding your research, by efficiently searching for that particular topic that you would like to do so. All right. Okay, so the next, as you can see, I'm showing you a website that has Google search operators. All right, and this website, we'll send the link later on the chat as well, and we'll probably share this PPT with you. But basically, this Google search operators, you can go through these, and I don't use a lot, but a lot of you can optimize your search results by using these search operators, like using or and what dollar does it searches for prices, and if you're defining some particular thing, that open a dictionary built in Google itself. So Google allows this. You can't do this in other search engines like DuckDuckGo or any such thing. And if you're looking for a particular site, then you can write this particular word, and it'll just limit your searches to that particular site. Now what you could do is also go on to, like we talked about, Google Scholar. Now Google Scholar is it's something that everyone uses, and it's something that has become really big because of the fact that it also uses BERT, and it also uses the PageRank algorithm in order to sort out the papers right in front of you. And what it does is that what it does is that if you're looking for anything like text summarization, you'll only get research papers in this. Now, I had forgotten to tell you that if you're looking for like NLP research, and you just want your research to be specific to IEEE, okay? So I think you're right. Okay, so, right, 1 second. Yeah. Now you should get all those, you should get all NLP research items that have been published in the IEEE website, and the journals and its entire magazines as well. So you should get only those search results. So you can optimize your search results like so. And the Google Scholars, now if you see in Google Scholars, now you're just getting papers and review papers and articles that are related to text summarization. If you just write Hindi over here, you'll get something that is much more specific, and you can look and optimize your search results like this. All right. Okay, so just a second, I'll stop presenting. All right. Okay, perfect. So these are just some examples of search operators that I had talked to you guys about, and they should help you in order to efficiently look and efficiently look for the topic that you would like to, and keep making efficient, basically. This is why, I think I've stressed upon this a lot, as in we need to do our work, we need to do our bit for the environment. So it's very important that you efficiently look for your research papers and don't delve in a lot of wasteful Google search, because of the fact that the Google does, like I did talk to you about the statistics beforehand, and Google does occupy a lot of the carbon footprint of the internet, and that's why it's very important to do efficient searches. All right, so I think this is it for me. I will now hand over the presentation to Aditya Nirmale, and he'll talk to you about what to do after you find your problem statement.
Hello, yeah. Can you hear me? Okay. Hi guys, so I am Aditya. So before we start, if anyone has any questions pertaining to Supriti's part, they can ask them in chat or raise their hand right now.
Right.
Okay, and also do one task. Also do one task that just write your research, since you all are here to attend and like, learn about research. Please write your research interests in the chat so I can know like what topics are you looking for, and like we can make it generic to that topic. So just mention your interest, like subfield wherever you want to learn or like you want to research in. Just mention them in the chat.
It can be a very vague thing. You don't need to be really specific about it or any niche topic. What you could do is that it could be a very vague topic as well. All right. So maybe you're interested in mechanics and mechatronics, or like, robotics in sense. You can even write those fields of research that you guys are interested in, and maybe he'll cater to you accordingly. But does anyone have any questions before that, like on the topic that I talked about, or like, how efficiently can you search?
I hope everyone can type in the chat. If you can't type, can you like anyone can raise a hand? Just let me know. Chat is not available. Okay, right. Okay, then we'll like turn. Okay, right. So if you have any question or like anything to say, just raise your hand. We'll unmute you. Yeah, we have allowed your mic. Yeah. Hello. Hello.
Yes, Ria, you can unmute
Yeah,
it.
sorry, it took a while. Yeah, it took a while to unmute. Yeah, I think for me it's a biomedical research that I'm interested in, healthcare research, for me at least. Yeah.
Right, that's amazing. I think a lot of work has been done in biomedical research as it is.
Just
Okay, so in order to make it interactive, we'll change the permissions and make all of you guys be able to talk properly. But before that, maybe what we can talk about is that I think the one thing that I forgot to iterate upon is that how do you like properly find that problem statement that you would like to work upon. All right, so what happens is that like I said, that's the reason why you would like to work on a particular research paper, right? uh, Now what you do is that, okay, so we'll talk about like how to come up with a problem statement of yourself. If you have narrowed it down that you would like to work in artificial intelligence, basically how do you find out like which subtopic is for me, how niche should I go on a particular topic, or how do I start my research? Basically, I'm sure a lot of you have these questions, so we will probably talk about this. further on as well. But I'll start by telling you guys that first, of course, like I talked about, a fundamental knowledge about how to particularly start, so that you can understand the research papers that you have probably that you would probably begin reading. What you do is that you start you start reading those research papers. Now what happens is that when you start reading research papers, you start understanding a lot of the literature that has been written in it, and then you start understanding whatever previous work has been done in that particular subject. And then what you do is that after you read it, you try to find limitations in that paper. That usually helps you in order to find a particular problem statement. Or what you can do is that question. So this is very important in any researcher. You need to start questioning, why is a researcher choosing this methodology and not the other methodology? Why is a researcher probably using anything basically? So this is what we're going to talk about right now in the next section of the presentation, and all of these questions will be answered. All right. Over to
Okay,
you,
thanks.
Aditya.
Yeah, we have given access to speak for everyone. So if you want to just tell me about your research interest, you can go ahead and tell me, and then we can start.
Hello.
Yeah, hello.
Yeah, I'm audible.
Yeah, yeah.
Yeah, so I'm actually from mechanical background, but I got interested in physics and quantum computing. So as she also mentioned that we need a previous background knowledge even to be able to read research papers well. So I was not sure how to begin with. Should I just run through the papers and then eventually I will get used to the jargon, or should I do some courses before?
Right. Okay, so we'll touch
Uh,
upon this in this particular section. So thank you for letting me know that.
yeah, thank
Any other person who wants to share their interests?
I'm
Like ask.
interested in robotics and like path planning, navigation. So just wanted to know how to go about looking at research papers for that.
Okay. Okay, fine. If no one else, then we'll start with the formative question. So, as Supriti mentioned before, like you can search like anything related to your interest fields. And once you get to know your interest field particularly, let's say like someone said quantum mechanics or quantum computing. My own research field is electronics, particularly. Someone else said robotics. There was another person saying biomedical. Okay, so you have narrowed it down. So you have that field decided. Now, what you need to do is try to look at the problems there are. So that is the inspiration striking thing. So let's say we got into quantum computing, quantum computing. So what's been happening in today's world is you have liquid nitrogen based quantum computers and liquid helium based quantum computers. So you have those like super cool quantum computers, and you might think, why not just have a quantum computer, a supercomputer that can work at room temperature? It's much easier to implement. You might even get one at your house. So that can be a inspiration. So that's what basically we're going to talk about, and like what to do after you get that inspiration regarding that particular topic. Okay, so this is just something I put. This is a 1992 article about the growing accessibility of science, and as you can see, it's behind a paywall. It's quite an ironic thing that whenever you go to read research papers, they might be paywalled, or they might like you might have to pay like $10, $15. So like here you have to pay like $200 for a journal subscription for a year. Again, that's not
Your
feasible.
screen is not visible to me. I'm sorry.
Sorry,
I'm sorry to interrupt,
uh,
but your screen isn't visible to me.
it's not visible. Sorry,
If you're showing something, I cannot see it.
yeah, just a minute. Share it again. Right, I've shared it again. Can you see it?
Yeah, I can see up your wall. Thank you.
Okay, so yeah, so you have the idea where you want to work in, and you have the inspiration. So let's say we're just taking that quantum computing example. I want to make a computer that works at room temperature. So what should I do? Well, I have an idea. I have the subfield. How should I begin? So first, as Supriti said, Google and use Google Scholar. But when you like use them, what you face is this biggest problem, that is a paywall. So I've just attached a couple of resources that we can use. So this is SciHub. This is one of our seniors' papers. And the funny thing is he himself doesn't have access to it after 1 year of publishing it. So SciHub is a website where you can access research papers for free. It's technically not legal. I won't be endorsing it, but yes, you can use it. Uh, there's an exception to it in the copyright laws if you want to Google it up. But yeah, SciHub is a lifesaver for all the researchers. So you can literally get all the papers for free here, or else you'll have to pay like $5-10 for every paper you read. Another resource you can use is LeftGen. So you want to read books related to your topic. Since like we are in third year right now, we have our GRE and TOEFL, IELTS preps coming up. Like we can even search books for those over here. This website again not strictly legal, but you can like you will send you this links later as well. Not strictly legal, but that's very helpful in researching some of the resources we use to like get started with research. Another thing to keep in mind, since these sites are not strictly legal, the links keep changing. You'll have to check on your own which link is available at what time. Okay. Continuing, so let's say again quantum computing. Coming back to that topic, it's not always feasible to know what quantum computing materials or the device you are using will be working or not. So you can't directly experiment, or like multiple experimentations might cost you more money, or it might not be feasible as such. So you can use software. So again, software resources. You have websites such as Get Into PC and FR5. So yeah, these are the websites where you can like get resources or like software. So I've just searched Proteus over here. Proteus is one of our like if any ECE student knows that EC or triple E student, Proteus is one of the most useful, like one of the useful softwares in electronic simulation and all. You also have Altium Designer, PCB Designer, and ANSYS, etc. Like simulation softwares, material simulation softwares you can find. Yeah, like generally you can find anything on these sites. Again, not strictly legal sites. Uh, but yeah, these are helpful because these softwares will cost you anywhere from $100 to $1,000, $1,000 for a year of subscription. And yeah, as researchers, it's difficult to get those. Right. So those were just some resources that I wanted to touch upon that you can like refer to while getting started. So we'll come to the major part of this section. So that is the literature part. So getting started, I've just mentioned a pre-review here. So okay, you have found your field, you have got an inspiration. You want to make a quantum computer that's working at room temperature. So what do you do now? See, the guy said that he was from a mechanical background. So what he would do first of all is maybe go through YouTube videos and then observe what is exactly quantum computing. Uh, YouTube videos, there are great channels about it. You can learn minute physics and everything. Like, those channels are good. Like, there are educational channels. Veritasium has talked about quantum computing. So yeah, you can go through YouTube channels. They will give you a very, very basic understanding, a very fundamental base about what your topic interest actually is. And then you can probably delve into courses. So we have edX, you have Coursera, NPTEL. Yeah, so and these courses might help you like more make a more concrete fundamental of what you want to actually learn or research upon. And yeah, they will provide you with literature information. They will provide you with references. And yeah, again, it's not compulsory to attend the quizzes or tests there are. You just need to learn. So just it's best to always refer the content they provide. And the biggest resource of them all is the textbooks. So textbooks, yeah, again, like we have all referred textbooks. I don't know how many of us have actually referred textbooks after joining the engineering college, especially when it's online. Most of us might have just relied on our slides, but textbooks are important because they might touch upon things where the things you might not have known before, or they might give you an avenue into something new itself. So textbooks pretty important. Again, you can use LeftGen for textbooks. Uh, yeah, so this is the pre-review part of it. So you build pre-review generally consists of building your basic knowledge and with your aptitude towards that particular subfield. So if you don't know what that subfield, do a pre-review, learn about it, get into it, build a strong fundamental towards it. Uh, Once that's done, that then comes your literature part or the literature review, literature survey part, you can say. So the survey part will be inclusive of the Google searches, using Google Scholar, using various publisher websites like Elsevier, ACS, Wiley. Like you can just this will majorly involve searching for research papers, particularly towards your interest area. So when you say quantum computing, let's again coming back to that example, it's better to explain with an example. Quantum computing. So you'll probably first go into what type of like how has quantum computing evolved. So you will try to search papers regarding those. You might even have papers regarding like what type of quantum computing materials you can use, or like materials that can be used at a higher temperature or something like that. So depending on that, scientific literature is classified into four parts that's mentioned over here. You have analytical, empirical, simulational, and review part. So whenever you will like, I'll just give a gist of all of them. So analytical papers are basically the papers where it's just theory. So they have taken in some hypothesis. They talk about other references where like references like other scientific literatures and textbooks. They take that hypothesis, give a substantiated information towards it. It might be mathematical calculations, something like yeah. If you talk about again materials, you will have integral calculation, different calculus basically. So yeah, probability calculus. That will be the analytical paper. You just do calculations basically. It's theory based, and then uh, they put that compiled data and their conclusions into that. You have empirical papers. So empirical papers are basically the experimental papers. So that's the one of the most common types of papers you'll find. So yeah, like empirical, any experimentation the person has done, or any. So in case of quantum computing, have they actually tried a room temperature material, or have they tried to cool it, heat it up, and see what happens? So those kind of papers you will find in empirical papers. Coming to simulational papers, this is somewhat of a new field, you can say, for non-AI or CS related research. Simulational work has like, picked up within the last 10 years or so. And simulational, again, as the name stands, these people just use softwares. We have material simulation softwares like Schrodinger, VASP, and all. We also have electronic simulation software. We have like this we have robotic simulation softwares like the Zebo and all. So yeah, basically simulation softwares. You don't need to exactly implement your solution in real life, unlike empirical papers. And yeah, so they give you simulation results, and these can be any vast bounds on any extreme conditions that can be possible. And then coming to the fourth type of paper, one of the most useful type of paper that you will find when you get started with research, it's called a review paper. And review papers, these papers are generally summarization of what all the research has been done in this subfield. It might pertain to uh, like the development of the technology. It might pertain to a particular niche in the technology or something new in the technology. Basically, a review paper will just give you a summarization of all the papers there are. And review papers, I can say, if you take it from the trusted source or a publisher, then these are one of the best papers to go by because review papers cannot be published by like like anyone, like any person that just shows up. For a review paper to be published, you need to have considerable research in that particular area with high citations and high recommendations. So review papers are generally published by top researchers in the top colleges and the top institutes. Uh, and again, as I said, one of the best resources to start navigating with your literature. Uh, so what you can, like, what general process happens is when you start learning about the topic, you can go into one review paper. Let's take the quantum computing example and come back to that. So as I said, we'll look about the development of quantum computing, what has been done. So you will probably go for a paper that talks about quantum computing's past and the future and what has been done for now. And the best thing about review papers is they will cite the paper, like they will give you references and cite the papers. What the citation is, Aman will be talking about in the next section. So yeah, I'll just mention it as a short thing that citation is basically referencing someone else's data or experiment towards in your own manuscript or content. Okay, so these review paper, what the best thing is that they cite the papers and like concrete papers from other top researchers, and that way what happens is when you it's effectively reading one review paper is effectively reading 25 research papers because they give you the main gist and the abstract, the conclusion, and the novelty of that particular research paper. So review paper, the best way to go. Since you have the citation to it, you can just copy paste the thing into your browser, and look, you can open that research paper up if you think that's particularly interesting in your topic. So yeah, that was the basic part about how to you find research papers and what type of research papers there are and what how would you actually go about understanding it. So coming to the essential methods. So okay, you have found your literature, you have your pre-literature, you have interest, you have inspiration, you have the question, you have everything. But how do I get started? How do I actually do research? So this is a very common thing, the scientific method. I think most of you might be familiar with it as well. So yeah, so scientific method, you make an observation. My observation was, why is quantum computing not being done at room temperature? And that basically will form your question. So can I do room temperature quantum computing setup? So that will be your, so yeah. Okay, so that will be your question. Uh, then you will probably form an hypothesis saying that, let's say I have some, what is the limitation first of all? So what the limitation was that you couldn't do quantum computing at room temperature the because the quantum effect doesn't work. Like, I'm just hypothesizing here. I don't know exactly. Again, that's what hypothesis is. So the yeah. So basically, your quantum computers don't work at room temperature because maybe your quantum effects don't work at room temperature. You might not be able to read the spin of an electron or something like that. So that's my, let's say that's my hypothesis, and you make a prediction. What if I make a material that works at room temperature and gives me quantum effects that are amplified? So that's a prediction. When you say a prediction, it should be a feasible prediction, I might say. Uh, Predictions that don't really make sense can't help you in experimenting. So always make a feasible prediction, and then you go ahead with an experiment. This experiment can be a physical experiment, a fabrication of real life, actually going through with the project, or maybe it's simulation. So you make an experiment, and depending on the results of that experiment, you might conclude that, was my hypothesis right or wrong? And if your hypothesis were wrong, you reject your hypothesis and go back to it, start over again. If it was correct, you make your own paper, manuscript, that's the theory part. And someone else might observe something in it and come up with something new. So this was a scientific method that like most of the people are familiar with. But this is more useful, I might say. This is the engineering method. That this is what engineers do. So we have identified a problem. Uh, I will take another example, let's say like the recent project that I have worked in. So, recent project that I worked in was an energy storage device called as a supercapacitor. So, identified problem I found, like, we found the problem was that supercapacitor existed, but they didn't enough provide enough power, and like the applications they were suggested for like IoT or like wearable technologies or anything, they really didn't fit in there. So we identified a problem as that this device was not flexible nor it was a compact device. So we set out to like develop towards it. So that was our problem. Uh, so you choose the select. Basically, then the second step is the parameters and the possible solution selection. So what I mean by this is, so as I said, the compactness was a problem and the flexibility of a device was a problem. So my parameters will be again the size of the device, how big it is, can it provide, like how much power can it provide, uh, and is it flexible or not. So yeah, so basically those are my parameters. And what possible solution can I have for those? So my possible solution might be, let's say I squish it into a 2D material, like a 2D device. So can that 2D device be more useful? Let's say I printed, I use the, so your normal supercapacitor are solid rigid devices. So what if I make some device that is actually printed onto a paper? So that paper can be folded, crumpled up, and okay, your device might actually exist in that form, and it will be flexible effectively. So that is a possible solution that I can think of. Maybe I can think of a method where I make a 3D device and then press it down into a 2D device. Can that be a possible solution? You can think of those solutions as such. Right. Okay. So once you come up with, like, you conjure up some possible solutions, you will move on to the simulation and experimentation part. So again, in my if it's feasible, generally people go for experimentations, but simulation has been again on an uproar. So simulations have been like up to the top. So in my case, we did an experiment. What we did was just printed some conducting material metals onto a sheet of plastic, and then we put some electrolyte on it and just checked if it was giving us capacitance. And like, yeah, surprise, surprise, it was. uh, so okay, is it, so we'll do that, but was it good enough? I don't think so, because it didn't last. It Whatever I printed got ruined as soon within 10 to 15 minutes. It didn't give you enough power, and like it wasn't feasible to manufacture it, nor was it feasible to like use it with wearable technologies. So okay, so it wasn't the best solution. So we'll go back to the experimentation and simulation part, and we'll go through our other possible solutions that you can implement. So once you arrive at some particular solution that is feasible, that can be published, or that is something that's novel or that hasn't been reported before, you try to go towards the implementation part. So we'll implement that best solution, and once you, let's say that, so this stage will basically involve, so like, you have experimented with multiple stuff. You've tried printing on a plastic sheet, you can try printing on paper. I've tried different metals like silver, copper, whatever this best. What electrolyte I can favor? Is it like, okay, so like, I might go into a bit of technical that people might not understand, but the gist of it is that I'm just trying to explore whatever is possible and all the diverse discipline or all the options that I can explore for it. So I tried different types of electrolytes. Can I try solid electrolytes, gel electrolytes, liquids, gases? I tried everything. So, and we found out that, well, the best thing was a gel electrolyte with silver electrodes. And then we started to implement those solutions. So this implementation will basically try to develop something more concrete, I might say, or like something more displayable and presentable to the audience or to the research community. So this is what you do in implementation of your best solution. Right. Again, so once so you have implemented your best solution, you validate your results with your required specification. So my required specification was it enough powering, giving enough power to power my IoT devices? Yes, it is. Uh, maybe I was like I had the factor, was the device flexible? Yes, I could make a flexible device. Uh, can I like did I reduce the size? Yes, I did reduce the size. So when you have met your valid the required specification results, uh, again through determining or validating your results, that's the step when you go ahead with writing your paper basically. Okay. Again, so very brief stuff about what your result should actually be. So first of all, the novelty. So what I think my novelty in my project was that I could make a device that was flexible and that was two-dimensional. So that was my novelty. Again, this might not be this might have been done before, but you will have to find new novelties to develop towards it. Maybe I can say my novelty was the gel electrolyte. If someone has done that, then I can probably not report it. So I'll have to find something new regarding that particular field. Uh, and this might not come straight at first, but as you get into research, start reading papers, start understanding stuff, you might just think about this. Like when once you start thinking about these topics, you might just come up with some brilliant strike of like, some inspiration. That light bulb thing will be there, and you will know it. Okay. Another thing important, another important thing in your result should be the conclusion part. So the conclusion should basically involve whatever work you have done and just a minute. Yeah. Okay. Yeah. So the conclusion part should involve whatever work you have done and what is its implications to the real world. So what has it contributed to the society? How has it affected the society, or like how might it affect the society? That includes the future scope as well. Uh, and yeah, the real life implications, because like why should we accept your work as a research, and why would it be useful in the future or like for the public or currently, you know. So that is what you generally put in your conclusions. uh, when you say extent of work, you can take any topic and you can never satisfy the extent of research in any of the topics. You will have to limit your scope of work to some particular sub topics. Even if I let's say take let's say I take my own device, the flexible supercapacitor, I can say. So even in the flexible supercapacitor, there have been so many different methods of fabricating it, or so many different types of devices made in it. I'll have to narrow it down to something something very, very, very particular that I'm trying to target. So these fields are very vast. So again, that's basically what you need to mention front of your work. This way, what happens is even the reviewers, the people who review and decide to publish your work, know that okay, you have limited a scope to this, and then comes the main part, that what is the future scope of your work. So I made a device, flexible device. Can anyone develop upon it, make it more powerful, make it make it have some different properties, make it even smaller, or they use it with some of their own devices. So that generally comes in your future scope, I would say. Uh, so right, that was the major part of it. I will be handing over to Aman for the part of writing the paper.
Yep. Can you all hear me? Can you all hear me? Okay. So before we begin with discussing writing a paper, before all that, if you all have any questions based on the previous section, you all can ask it right now. You all can unmute and ask, or ask in chat. Any particular questions you might have had with the previous section? Okay. Okay, cool. Then. We'll start off with writing a paper. Research papers obviously come with research papers is what we are targeting at this point, right? Through this presentation, what we are going to work in our undergraduate years. So writing a paper becomes important with considering writing styles. There are multiple formats, bibliography, and how you check plagiarism. So all of this combined, it becomes important that one understands how to write a paper, at least while they are conducting undergraduate research. So before we start off with that, we would like to discuss types of publications. So types of publications, a publication in general can be described through in multiple variations, going by original research, which would be full-scale paper discussing your novel method, proposed method, or state-of-the-art method that you have deliberated on or discussed or proposed in your paper. On the other hand, there are short reports or letters, which are shorter versions of original research papers, which may not have considerable novelty or may not have considerable results to be made into an original paper. However, their results are still significant enough to be considered a research paper, which is what makes short reports or letters. Then comes review articles, which, as they're discussed, are an important aspect of the research community in general because they summarize as well as not cluster, but categorize multiple papers which are of relevant topics together, allowing people to review over system descriptions or topics very quickly over a single paper. On the other hand, there are certain problem statements which are really important for certain areas or subfields within research. For example, if picking the topic of natural language processing within artificial intelligence, we have machine translation, where a particular data set which is vast enough to be considered a case study could be attributed and given off as a data set where multiple algorithms are analyzed, multiple papers are and multiple methodologies are analyzed just to beat or to overshoot or to work to improve that performance on that particular, say, data set or case study. These are case studies where you take in a particular topic which is localized within a particular set of a particular problem, and you discuss that in detail. Then comes methodologies or methods where you have papers which describe particular methods or propose different methodologies which might be relevant or novel in their field in their fields. Patents, on the other hand, have a special connection towards research as they not only describe a novel method, but they also give a much better standpoint on an industrial point of view as well. So combined, all of these are important aspects and are types of research publications. Going ahead, now before you take the leap of publishing in a journal or publishing in a paper, you must understand that there are multiple parties also involved with research, which would be there are journal editors, there are publishing parties, there is a publishing team, editorial team, a reviewing team. All these parties together form a journal or describe a conference. However, it becomes important that when you approach a particular journal or a conference, you understand what these parties consist of, who the editors are. It becomes important who is in charge of the journal so that you can avoid profiteers who uh, basically exploit young or inexperienced researchers for money just to publish their work in a non-important, non-significant journal, where particular reviewing price is charged for per paper you publish, per paper you submit to those journals, and they are simply published without any review, which means the impact of the journal is very low. However, you're still publishing something, but since the impact is very low, there is no significant importance of the work that you have just completed. Uh, some ways or some questions that you should ideally ask before going after a journal. Who is the editor in charge of of journal content? What is the journal's process for ensuring quality of content? Does the journal have sound business and publishing practices? What to look for specifically once you have these questions in hand? A person who has a especially for the editor of the journal, the chief editor of the journal, the person must have reputation and in the discipline that they're in charge of, as well as be considered reputable in the field of research. On the other hand, checking for if we had to consider red flags for the same, if you cannot find any evidence of the editor having worked in the particular discipline, or if there is no contact information or any significant linkage between the journal and the editor themselves, it becomes difficult to map whether the journal is either a profiteering journal or whether it is a sound good journal. On the other hand, if you had to understand whether the process of ensuring quality is described in a journal, you would check their description. A clear description of the process of review must be present. The deadlines for reviewing, how many weeks, how many parties would be reviewing, as well as the reviews themselves. If in some cases there is mystification of those, then you could consider it as a red flag and may not want to view that journal as a prospect for publication. Then if the journal is an inane, not Scopus indexed, or does not have any sound publishing or business point practices, then you could still consider that as a red flag and not consider publishing in those journals. If you had to find, now that you know certain red flags and certain questions you would like to ask before venturing into publications, you could still find credible journals for your manuscripts, and there are multiple indexes where these journals are mentioned and can be confirmed, and their relevance can be confirmed. If you go to Directory of Nursing Journals, Directory of Open Access Journals, Schemago, and Journal Citation Reports, these are some common venues where you could understand whether a journal is credible or not. Yep. Then another set of useful information would be there is ThinkCheckSubmit.org, which uses other publishers or writers or authors to check journals in which they have published previously and understand whether they are predatory or, as previously mentioned, whether they are just profiteering off of your work. This website is really important because it's community driven, and it would really help to understand whether it would really help to check whether the point of publication is good or not. Other than that, there are multiple articles which define what predatory journals are compared to trustworthy journals where you would like to publish, and understanding how the process of publication actually happens, the reviewing process, and the amount of effort that goes into journal practices is important so that you could better evaluate whether the journal you're attempting to publish in is good or not. So a lot of times predatory journals charge a high amount of fees just to process your journal paper, just to review your papers themselves. So understanding that there is a linkage between citation score and the review pricing can be important, because it would help understand that if an indexed journal if a journal is indexed very low, you would understand that the review prices for it should be significantly lower as well. So that is another way, which leads on to my next part, indexing, which I would come to in some time. Before that, we'll discuss the format of the paper. So now why do we have, so journals and paper writing is important. However, we have to follow strict formats for it. Every journal or every particular conference has their own specific format to it, which they might provide you in a LaTeX Word or another format. Now, why is it that important to have a single format or a strict format policy? Now, we have had documented history since a long time. However, if the way we have documented it is so different and so global in nature that there are so many variations in which we store information, which is troublesome to aggregate and go through all of them together, which is why it is important that we have strict formatting for journals. Even across multiple journal manuscripts or overviews or formats, there is still some semblance, such as every journal would have an abstract, an introduction, relevant pointers, your work, and then a conclusion, which becomes important because having a strict format allows there to be uniformity in the work presented and also allows further reading or further information retrieval in the time of review. Now going into the details of what a paper is. So a paper starts off with an abstract. Now, an abstract is essentially a summary or a very short description of what you have completed or what you have showcased through your paper. A submission abstract is very important because this is the abstract summary which you provide to the journal, to the publishers, conference or journal, before you submit the entire manuscript in some cases, or some cases with the manuscript. However, this is what the reviewers first essentially read before taking a deep dive into your paper. So it is important that one understands that the submission abstract can make or break your paper acceptance entirely. And then coming to uh, manuscript abstract, which would be the final abstract which you would give for your paper once they have been reviewed and you have gone through certain steps of the publishing house. So contrary to popular beliefs, most senior researchers and professors ask you to write the manuscript after you have written the first complete draft of the paper. Now, this would be very relevant because although this is the first and the most important part of the paper, which you would ideally showcase at the beginning of the paper, it is important that you bring this, you write this towards the end of your entire work, because at that point you'll have a clear idea of what you have completed. There would be clarity in what novelty you have added. There would be better evaluation metrics which you could highlight through that small abstract, allowing the reader to better understand or quickly understand that yes, this work is significant. There could be graphs or comparisons made to existing work, where within the abstract itself, you could mention that you have boosted algorithm performance or certain weightage to previous literature by this much percentage. Or you could mention that this is the current state of the art, where you are the peak performance that has been occurring on a particular case study. There could be one statement referring to a very popular existing paper, which brings to light the comparison that you're making with the introduction of your paper, relevancy to the work done, and a statement regarding the application which this work now introduces. Although abstract is a really important part of the paper, there are multiple other sections within the paper. Starting off with abstract, which would ideally constitute 8% of your paper, since although it is one of the smaller sections of your paper, it is one of the most important parts of it, as mentioned in the previous slide. The next would be the global introduction, which would highlight the area in which you're working, such as even if we are going for, say, machine translation with the natural language processing, the global introduction would ideate over the entire field of AI and then maybe NLP. Before going to the local introduction, which would be your subtopic of relevance for your paper, such as machine translation, where you would be localizing on the work and the impact that is done with current algorithms, and you would give a brief introduction to even people who do not have any relevant research background. With both the global introduction and local introduction allows the reader to better understand the paper, the relevance of it, and the potential impact the field itself has. Now, going ahead, you would have explanation of the novel idea. Now, here it is important that before you explain the novelty of your idea, you also explain the ideas that exist within the field as well, which would be significant because it would allow you to significantly highlight what novelty you're introducing, as well as it would allow you to light up that your work has been boosting or improving performance by a particular percentage. Then comes explanation of your novel idea, obviously, where you propose an algorithm, ideate over why it considers the steps you have taken, and also discusses how it connects to previous literature and how that hypothesis builds onto your work, giving you theoretical support. Now, once you have built a significant structured theoretical support for your idea, you go on to evaluating it. The evaluation of the idea is slightly bit smaller than the theoretical presentation of it, because here you take multiple or particular data sets which are relevant to the field that you're discussing, and perform analysis of your proposed methodology over it. Evaluation of the data of the idea is important because it allows you to give practical or experimental performance to the idea that you have come up with. The explanation of the novel idea obviously gives you substance for theoretical proofs. However, evaluation of the idea gives you practical proof. A standard balance between both theoretical and practical is important However, since our theoretical approach also brings together previous literature, it is significantly larger than the evaluation of the idea. Now, inference and applications, the results that you have generated from the evaluation of the idea section of your paper would come into play for the inference, which you could take from your proposed methodology. Maybe certain attributes, certain algorithms which you have introduced have better performance, and now you could make claims, or you could inference claims that yes, this algorithm performs better for these particular tasks. And for future work, other readers, other authors, or other practitioners could use these particular algorithms to boost their performances. Applications, on the other hand, would be if, for example, you come up with a novel method for a new applications of, say, computer vision, robotics, or electronics. Now you could introduce this in this particular section where you can say that this particular methodology can not just be applied for, say, languages, it could also be applied to sound waves, something like that. Finally, conclusion and future work, which is also another significant bit of your paper where you tie up all loose ends, complete the paper and bound it together and summarize the whole paper, your significance of it, the work that you have done, as well as the idea that you proposed together in the conclusion, and introduce concepts that you may not, you may have overlooked in your research work, the hypothesis, which would come into future work, which other readers, authors, or practitioners could pick up and continue on. Finally, we have acknowledgement, which is obviously if you have been aided by certain fields, certain people, certain organizations in your work, then you could mention them, acknowledge their participation, acknowledge their contributions in the success of your publication. Okay. Now, tips and tricks for writing a paper. First of all, as said earlier, format is an important aspect of writing a research paper. Reviewers hate it when you mess up or you do changes to the formatting they're using. If they have given a particular idea, there's a particular reason for why they want figures in a particular method or tables in a particular way. And so, right, following the format is really, really important when you're doing research. Even small mistakes can put off reviewers, and they can generally write bad reviews about it. Talking from personal experience, we had a situation where one of our papers was mentioned that we had the image formatting wrong, and they wanted us to redo the whole thing. So there is particular ways which will delay, which will not just delay your paper, but also give bad reviews for the next set of review, like the next time you review your send your paper for reviews again. So formatting is really important for your research. Then second part would be, do not make bold statements in your manuscript unless you have actually done that significant work. Bold statements such as results shown by Zhang et al. Are wrong, or a particular author is wrong in what they have proposed. The algorithm proposed does not fails for certain cases. Some other author's work is bad. This journal has not attributed this proposed methodology successfully. These things are really bold claims where you are discrediting another author, another researcher, or another organization. So it becomes important that you do not do so unless you have significant groundbreaking results. It should not be like a single data set use case where, say, I have a particular algorithm. Yes, it was proven successful, proven unsuccessful over, say, 20 different data sets, and now I choose a new data set where it's successful. I cannot claim that the review paper or the case study that said that this algorithm is unsuccessful is now successful just because on the chosen data set that I have selected, it is working. So there should be significant groundbreaking work before you make such bold claims. Now, the use of word novel is very important, especially with research papers, because there are cases where you just take a previous algorithm and apply it somewhere else and you consider it novel. However, the algorithm previously existed. The novelty can only be considered where it's 100% your work. There is no previous literature on it, and there is no other paper which you can cite or you can clearly write a difference between a previous work which has been done and with your proposed methodology. Only then can you consider a particular method novel. Now, use of technical terms. So technical terms are obviously important. You should not English. First of all, English is a really vast language. There are different ways of saying different words. There are so many synonyms and everything. However, it becomes important that when it's a research paper, the reader understands what you're saying very, very clearly, which means your words must be technical in nature. There should be very less chance of confusion when someone reads your paper. For example, in a path planning paper, the vehicle should be referred to as a differential drive bot or a robot or differential drive robot. It should not be mentioned as a vehicle. You should have that understanding that yes, a normal reader who may not have that much significant research work done in not done in the field of robotics would understand that as an automobile, a car, a vehicle. So it becomes important that technical terms are distinct and are importantly mentioned in the paper. Now, avoid informal language. Reviewers hate information language in informal language. Now, obviously, you would want to have fun with the paper you write. You're having fun, but at the end of the day, it is a formal contribution to the scientific community, the community that you've learned from, and what you're working towards. It is a formal contribution. It is going to be recorded and it is going to be showcased for future researchers. So it's important that the language that you use is formal and direct in nature and not a simple hand wave. Not just that, if you use informal language, as previously mentioned, there would be confusion, there would be mistakes which others might look at within your paper and then question what you have done. Next part, read the past publications of the journal or conference to understand the writing preference. So it becomes important that when you're submitting to a particular journal that you understand what kind of papers the reviewers like or the editors like, which means that you would want to understand what their tastes are, how their way of writing is, whether they like particular language, whether they like different formats, which means that you would have to go through the previous literature published in these journals, allowing you to better understand that, yes, this author mentions previous literature over the years. This author mentions over the topics, or this journal mentions it over the topics. So you would better understand that, yes, there are particular writing styles which can be attributed to particular journals, and it becomes important that you identify this before approaching a journal for publication. Some journals, example IEEE Census Journal, are focused on application, which means they would be more readily accept an application-based paper than a theoretical-based paper, like IEEE Journal of Electron Devices. So it becomes important that you understand the writing style before approaching a journal for publication. Now, images, graphs should be of high quality. Obviously, you would not want readers to not understand look at your paper and not understand what it's about. Particular images must be high quality, since the paper itself will have a lot of textual data combined with lower quality images would confuse readers even more. So it becomes important that your flowcharts, your images, your inferential images, graphs, etc., of high quality and easy to look at. Now, one more thing is use actual softwares like Origin, TechPlate, and TechPlot, etc., and not use something like Paint just to come up for your images. Now, focus of the writing should be on the novelty factor. With this statement, I would like to say that you are attributing your entire paper for your data set, your approach, the results, the significance, the impact. Now, there are so many topics that you have to go through. But at the end of the day, your focus must be on what novelty you're introducing to the paper and not the, introduction, the literature review and all that, because that's not the point of your paper. The point of the paper is that you have introduced this particular novel method. What is this method? What impact it has had? What performance it shows? Even if you have just made a small modification, it should be highlighted and it should be emphasized within your paper. In terms of review papers, obviously the emphasis should be on what inferences you can derive from all these papers or the multiple papers that you've gone through. But still, at the end of the day, the emphasis of a paper or a research publication should be its novelty factor. Then finally, the language. obviously we have discussed the importance of formal language within the paper. However, it becomes important that you understand that particular journals would prefer certain types of language, certain diction. Several sources are available from, say, Oxford and Cambridge, etc. Now, finally, something important would be references and bibliography, where uh, it's important that when you cite another author's work, that you give credit to them, and in that sense, you reference their work, so you give citation. Several reference managers exist, such as Mendeley, MS Word plugins, etc. are there. It becomes important that everything that you are taking from another person's work, you mention, cite, or credit, give some credit to them. Obviously, with that also comes, be careful of the writing style, of the referencing style. There are several styles that exist: APA, MLA, Chicago, IEEE, International, etc. Even one of the most BibTeX is becoming another popular method for citing. Now, error in doing references can get you into a lot of trouble with reviewers, where if they realize that, yes, certain work has been ideated over in this paper, but they have not mentioned or they have not referenced this paper, they could consider it a malpractice for publication, which could get you into trouble, even for future research. Now, with that also comes plagiarism checks. Now, you may have come up with a particular method. You may think that you're novel in that nature. You may think the performance is the best and no one else has come up with that method before you. However, this is obviously a really great thing that you've come up with a new method, but there should always be a plagiarism check where you at least go through the internet, at least go through other papers with similar topics so that you understand and you're 100% sure that your work has not been repeated by someone else or has not been previously done by someone else. Because if done in like that, then the reviewers figure out that there is a connection between your proposed methodology and someone else's. There would be a conflict of interest, and you would be plagiarizing that person's work, which is, in a sense, stealing someone else's work. So there are several softwares that exist to do plagiarism checks, such as Turnitin. Journals and conferences use this, use 15% in Turnitin to understand whether you are performing plagiarism based on a particular another author's work. Now, there are certain, obviously every journal has certain acceptable percentages because everyone understands that particular work would be repeated in multiple papers. So with respect to that, elite conference and journals would have a really low plagiarism percent limit, where it would be 5 to 15%, and the Turnitin limit would be 5 to 10%. And good conferences obviously would have a slightly larger margin, with 10 to 20% coming in and 15 to 20% for Turnitin coming in. Now, moving forward from writing styles, paper formatting, and plagiarism checks, let's come to database of journals and conference proceedings. Where can I look for a point of publication? Where can I go to find journals? Where can I understand that I can publish something? So there are databases of journals such as Scopus, Springerlink, Word Catalog of Scientific Journals, Journals Directory, and Google Scholar. These databases, including for conference proceedings such as IEEE Explore, ACM Digital Library, ASME Digital Collection, Conference Proceedings Citation Index. These database collects and aggregates multiple journals and conferences, all points of publications, allowing you to find relevant conferences relevant to your work quickly, giving you more publication points for projecting your work. EDAS Conference and Journal Management System manages the paper submission, review, and registration process for conferences, workshop, and journals. There are even more points such as management systems such as CMR, etc., which are new, and they are being used for new fields such as that, like AI, etc. Moving on, we have, so now you have a writing style, you have formatted your paper, you have done a plagiarism check, you have cited the relevant authors, and you have found a database of papers. Now, how to select a particular journal relevant to your work? You have multiple journals which are relevant to your work. How to figure out which of them is the best for you. Now, credibility is an important aspect of research and is measured majorly through the amount of citations your paper has. A citation is when one paper explicitly gets referenced in another paper, which means that yes, I have introduced so and so methodology, but it was inspired by this other person who has written this paper, which means I'm citing this person's paper and their work in my paper, and I'm attributing my work as a support or a future work of theirs or an improvement to theirs. Some basic metrics to understand whether how credible a journal or conference proceeding is are quartiles, which would be there are essentially four quartiles which rank different journal conference proceedings, etc., into four sections, which would be based on credibility and impact of those journals. Q1 journals are obviously the most impactful journals and have put out significant work into the world. Q2, Q3, Q4 follow up in their order of impact and significance. Now, moving forward to other metrics, there is impact factor given by metric scores like journal citation reports, JCR, Schemago journal country ranking, SJR, source normalized impact per paper, SNP, and site score. Each of these have their own relevance, such as SJR also brings into account the reputation and the credibility of the team behind the journal itself, etc. Whereas source normalized impact per paper brings together the concept of normalization within the particular field that the journal is targeting, such as it would not conflict with, say, artificial intelligence and chemistry. So they would have their distinct SNP values. Looking forward, there is H index, which is another metric, which is another rather popular metric for understanding how credible a journal is. However, it should not be taken as the most weighted metric, because after all, the newer metrics, which are impact factor metrics, are significantly better in understanding how credible a journal is. H index in its essence is how cited your paper is with the number of publications that you have made based on a particular journal. Cited half-life and citing half-life are variations of impact factor metrics themselves based on half-life cycle of the particular year of publication. Moving forward, I think we are done with metrics, and so tying all loose ends together and tying up everything. You have formatted, styled, introduced methodology, proposed a novel method, brought together what you're writing, gone through databases of journals, and finally selected a journal for point of publication, which brings together a process of undergraduate research. And yeah, so thank you, everyone. If you have any further questions, you can run through.
Since the chat option is not available to attendees for some technical reason, you can just unmute and ask your questions. Okay, we'll just share a link as well. If you don't want to ask, you can just post it on that link. I will be sharing that. Just give me a minute. Okay, right. You can just type this link in the web browser. We're also trying to send this link on the event group itself. If you have any questions, you can ask there. Or you can unmute.
Hello.
Yeah.
Yeah, so the formats that you mentioned for publishing the papers, they vary from publications to publications, right?
Yeah.
So when we do not know in which publication we are going to publish without getting done with the research, is there a recommended format in which we should first write down all the material that we have for our research and then convert it into the format that is needed by publication?
Yeah, if you could. So if you go back to the pie chart slide, yep. So if you can look at this format, which is the composition of a general research paper, it would be abstract, global introduction, local introduction, explanation of the novel idea, evaluation of the idea, inference and application, conclusion, future work. So ideally, every single paper has these particular sections within them. Obviously, acknowledgement may or may not be in your paper, but the rest of them are generally, this format is generally followed for every single paper. So, yeah, even if you don't know your point of publication, their format, ideally you would still space out your paper in this way.
Yeah, thank you.
Okay, someone asked in the chat about like what the recording of this meeting will we share? Yes, we'll upload the recording of this meeting to our YouTube channel. And, uh, if you have any questions, you can put it on the link or unmute and ask. We will share that link on the WhatsApp group as well for the event, so it will be convenient, or you can just type it on your web browser.
Am I audible?
Yeah, yeah.
Yes, so I had this one question that in the initial of like in the very beginning of the meeting, ma'am said that if you are like specific with what you want to research, then you can go like this. But how do we like come to a conclusion that we have interest in this? Like how do we make our interest on something? How do we find our interest?
Right. Okay. Okay. So you know what your area, like, what do you want to work with? Do you know that? First of all, do you
No,
know the
not
topic?
clear with that too. Yeah, not
Right. Okay.
exactly clear with that.
Okay. So there must be something that you might find intriguing or interesting, right? So something
Mm-hmm.
like for the case of Aman, he started working with cybersecurity, and then in cybersecurity he learned about something called as AI. So AI was his subfield of interest. I started with making small robots, and then I learned that yeah, electronics seems interesting, microprocessors. There are laptops where you have chips. So this seems interesting. So we went to that. Like that's how we generally decide our area of interest. So there must be something in your mind that you might want to uh, you might want to learn about or understand about. Right.
Got it. Thanks.
So okay. So, do you have a topic related to it particularly?
So like I have multiple interests, so that like I'm always in a dilemma that which one to go with. That's what the problem is.
So the best one of the like, there are like couple of advices. Uh,
Mm-hmm.
One way to be would be that just go with what you are actually majoring in and might help you in future. So let's say I'm doing in electronics, then I'll probably do research in electronics or AI. But it's not limited to that. Obviously, we don't limit ourselves to that. One
Mm-hmm.
of the best ways
But
would be to do with that.
yeah, thank you so much.
Okay. Okay. So questions are coming in. I will just show them on the screen. I think Aman can take this one.
Yeah. What's exactly the difference between abstract and introduction? Now, um, although they do kind of sound similar, your abstract is very limited. So you would say you'll have only 180, 150 words, maybe 200 words for your abstract. Your introduction would be significantly larger, introducing your topic much more broadly. Uh, Introducing not just your topic but your area much more broadly compared to the abstract. The abstract also puts out what impact your work is having and a comparison, right? So you would also be mentioning that yes, I have this much percent improvement from the previous literature, or this much significance, or this much impact improvement in my novel approach that I'm introducing. On the other hand, introduction would only discuss the field in general, the impact of the field, not the subject or the proposed methodology itself. So it would be generalizing over the entire field, introducing a non-research oriented reader to the whole topic in general. I hope that answers your question.
I think this one also DL is interest field.
Even I'm really interested in deep learning. So if DL is specific to that, then I would say that um, obviously deep learning papers are much more complex compared to say machine learning papers. So ideally, you would start out by understanding how to convert machine learning papers into code. And then slowly, once you get an intuition, a better understanding of the topic in general, you would move towards organizing, say, deep neural networks, organizing improvements in that or variations in that, so that you could build up a concrete ideation towards implementing DL papers into code. So it's taking smaller steps rather than jumping into deep learning. I would suggest you starting off with machine learning, building to neural networks, building to architectural differences in different kinds of neural networks, and then finally deep neural networks. So yeah, it's you can't really take jumps. You would have to start off with smaller steps from machine learning to deep learning. So yeah.
Okay, right. How to start with writing a research paper? So since there is not a lot of clarification here, I'm going to assume that you mean if you have everything ready, you have the results ready, and you're done with your experimentation part, you have got your best solution ready, or you have validated your result. So how do I start writing it down? Best way to start is what I do personally is I write down what my novelty is. So as Aman mentioned, novelty is 28% of your paper. Very, very important. Again, coming back to that pie chart. So very important. So I just list down what my novelties are. And again, like there was another question the person asked, how do I exactly know which format to submit it in? So depending on what your novelty is, you can probably gauge how good my paper would be and like how good quality or impact journal that paper can go in. So you can probably start looking at those journals and then just see. So let's say I have a novelty in my paper. I have like three novelties in my paper. I made a flexible device. I made a 2D device. I make a gel electrolyte. Those are my novelties. No one has demonstrated it before. So three novelties, yeah, decent. Let's say I target a quartile one journal, and if you will learn about impact factors once you start reading the papers itself. But yeah, so okay, so like once you start reading the papers itself, but you can like gauge where three novelties would lie. So okay, three novelties is better than one or two novelties, so it might be on a medium spectrum somewhere. Let's say I take a six impact factor journal, and I will start looking at journals that are particularly relevant to my field, and look at what they have written in their paper and what is their flow. The abstract, global introduction, local introduction, all of them remain same, but they might arrange the data differently. So they might have your evaluation of idea before you actually infer inferences might be before, or like proving the idea might be before, describing your stuff. It might be interchange. So you just go to that journal, probably look at the paper, and start writing it. Apart from that, yeah, since I told you that list down your novelties, best way to start your paper is uh, start writing down the major section that you know about. That is your novelty. Describe it, what you have discovered. Put down what experimental methods that you use. How did you go about it? Another important thing I might have missed to mention was whenever you write a paper, write the complete information in it. It should literally have everything you have done because that results need to be replicated by other people as well. And if your results cannot be replicated by other people, then that might not be considered as a good research because you're trying to hide stuff from them. So yeah, write down about whatever you know the best. And for the other sections, as you start writing it, you might realize, okay, this is some concept that people might not know about. So I need to introduce this. So you can just jot down the points from there on out. For inference, like for the conclusion section or the global and short introduction section, what we generally do is we find papers similar to our papers, typically from the journal you might try to find, you're trying to submit to, or the publishing house you are trying to submit to. So you try to find papers that are similar to your papers, draw contrast, give references to theirs, or what have they done in the past and how are you building upon it. So that's how you like start writing research paper. It might include a very basic manuscript, might not be properly formatted at first, but before submitting, yes, it's important to format or else reviewers won't like it. What all can be cited from research papers? So, to be honest, you can literally cite anything from a research paper, whatever is written. You can, if you want to use figures, you do need permissions from the publishing house and the authors themselves. It's a lengthy process, but it's a simplified process. But you can literally cite whatever it's written in the text. You can literally cite anything, unless, let's say, I have mentioned, like, I'm citing some paper saying that flexible supercapacitors were used. Okay, let's take another topic. I can't really give an example here. Okay, so we can talk about vaccines and COVID basically. So, uh, let's say you're citing from a paper that says. Two doses of COVID-19 Covishield have proven to have efficacy of 83%. Now, if this is an original data from that own paper itself, you can cite it directly and then cite the paper name where you took that data from. But if they mention some number in the bracket, that is that they are using that information from some other paper, you cannot cite the paper where you are reading it. You will actually have to go to the paper that is being cited in that other paper. It might sound confusing, but you'll have to go to the original paper where they have written, where the original idea came from, and then you'll have to cite it. But as for citing from another paper, you can literally cite anything they have written. Uh, Aman, you can take this one.
Yep. So my fields of interest also lie at the junction of cybersecurity and AI/ML. So, starting off with beginning research or beginning work in cybersecurity and AI/ML, I would first say get a brief overview of the field itself, not for with respect to research, but the field itself. So maybe going through basic cryptographic concepts or maybe basic networking concepts, something which is relevant to cybersecurity, and then something like deep neural networks, or machine learning algorithms for AI/ML. And then once you're comfortable with both fields in general, you could move ahead and look at junctions of the fields together. So something like intrusion detection, anomaly detection for in within networks, which bring together DOS attack detection for cybersecurity using AI/ML to improve performance. On the other hand, you could have privacy preserving machine learning, which brings concepts of cybersecurity within machine learning algorithms to preserve client identity or anonymize their data. So, yep, you would start off with, again, smaller steps where you understand both topics in general and then converge on something which combines both of them. So, yeah.
Okay. I have an algorithm in mind for trajectory prediction of a ball, and there are multiple papers on the same. I'm not sure if the algorithm I was thinking is exactly worked upon. Also, there are differences in the dynamics of different balls, so I can have a different solution. Okay, so I'll take this from a novelty standpoint of view, and Aman can go into the algorithmic part. So, as for the novelty standpoint of view, if you are considering different balls having different solutions, it can be considered, but it's kind of exploiting a loophole, and that's frowned upon in research. So try to come up with novel solutions as much as possible. If you have nothing novel but you have significant work or something to demonstrate, maybe yeah, you can use it. But it this kind of it's a very small novelty, so this kind of work might not have as high impact, or like you might not get a better impact publication as such. You might try to include another like higher types, like higher discrepancies or better types of novelties. Another is you said if you're not sure that the algorithm is exactly worked upon, uh, try implementing it. Results are the best way to match it. So if you think the results are being replicated somewhere, what methodology have they used? Or like you have very similar errors to some, like, it's an algorithm, right? So if you have similar errors to or like the prediction to what other papers have demonstrated, what's their idea behind it. So is your idea similar to it? How is it different? That way you can probably gauge the novelty and know if it's worth publishing or not.
Say from an algorithm point of view, if you have created a different kind of algorithm, it is obviously interesting and it is obviously a good thing in general. But yeah, as Aditya said, you would have to consider the point of novelty even within the algorithm. Uh, the fact that there might be a different solution and you're not aware, I would suggest going through the literature, a vaster sea of literature before moving forward with your claim that it is a novel method. Because if you're unsure, that means you yourself are having a doubt whether you have gone through enough research to consider it a novel methodology in itself. So go through more research work, go through topics which are similar, highlight papers which are coming closer to your topics or which you've taken inspiration for, find papers which are connecting those, which are citing those. So try to find, try to make sure that no one else has done it. And even then, obviously, novelty is kind of an issue, in which case you could consider this a case study where you do not consider it a research, a full scale research, full blown research paper, but a very specific topic in general. Uh, so, yeah, in that's a different case in general. But yeah, definitely go through more literature before moving forward. From an algorithmic standpoint of view, it's really great. And even if it does not come off as a research paper, it would definitely be an interesting coding experiment, and definitely do that. Make experiments, point out inference and project your results from the algorithm itself.
Okay, on what note should I start research on aerospace? Should I follow some general structure has been adjusted to, or do you recommend something extra? So again, this might change on case to case basis. It might depend on how much prerequisite knowledge you have with the field, how you new are you to the field, and what what have you thought about till now. So if you are just getting started with the field, as we said, go through courses, YouTube videos, textbooks, build a base towards it. If you have significant knowledge in the field and want to research in it, so identify problems around you. Like there are quite a few problems in aerospace. Propulsion systems is one of the aerodynamics, the materials used in developing your space, aerospace. What would you say? Satellites and rockets and everything. So identify the problem and what problem is particularly interesting to you, or like what problem you can try to solve with the prerequisite knowledge you have. If you find some another problem interesting but might not have a prerequisite to it, again, yeah, textbooks, yeah, like learning, literature reviews, papers, that's the way to go ahead with. Uh, and yeah, so once if you're very new to research, you will have to start with the general structure, that is reading papers, understanding the literature, developing an idea, identifying the solution, experimenting, and then maybe getting the best possible solution, validating, and then writing an answer. But as you get more acquainted with and like frequented research, you might have explored so many papers and journals or like new researchers by then you will be keeping up to date with it. That you might just strike up with an idea. You might not need to perform that literature review before starting your work. So initially, just follow the general structure, and as you like learn more, you will adapt to it mostly. Right. So there aren't any more questions. If anyone has, they can unmute or they can write, and we will be concluding. Otherwise, right. Okay. So I think no one has any questions. So we'll be closing it down. Thank you all for attending. I think if you guys, you can take it. Hello, Satakshi.
Yes, yes, I'm right here. All right.
So with RSM's permission as well, I guess we'll conclude this session. Okay, perfect. Thank you so much, everyone, for taking our time and joining. Once again, thank you so much, RSM, for giving us such a detailed and informative session. I'm sure everybody has a lot to take away from here, including, how to get started and then what to do after you've gotten started. And even beyond that, I think it was incredibly detailed. And for that, once again, thank you so much. To all our attendees, know that you can always reach out to us on our respective Instagram handles, RSMs and ACM Manipals. We would always be there to guide you in any form that we can. And with that, I hope you have a great rest of the day ahead and an even better research journey. So thank you so much for joining.
Thank you all. If you have any doubts, any further questions you want to talk on one-to-one basis, yeah, you can approach us anytime. We are free.
Thank you, everyone. Bye.
Thank you.